Okay, so for dilations, we talked about scale factor, we talked about center of dilation. What's the most common center of dilation? Yeah, the origin is the one that you have to know mostly. That's where all of the formulas come from, assuming that you're dilating around the origin. And then, how does scale factor um, affect the type of dilation? If it's less than what it would be reduction, if it's bigger than one. Good enough. Yeah, that's fine. If it's between 0 and 1, if the scale factor is between 0 and 1, if we have a reduction. If we have a scale factor greater than 1, it's an enlargement. But wait, I don't get it. How do I know what the scale factor is? It's the number you multiply by. Dilations are done by multiplication, so it's the number that you multiply by. Then we started some examples. We did this one. We did the one with the triangle. Okay, and I'm only gonna do one of these because these take a long time, and really it's not the most important. But I will do one of them because I know you're thirsty for knowledge. What's different about this one? Josh?
Well, if you switch them, they'll still be fine.
There we go. We're changing the center of dilation. So it's just a lot of extra steps. So, and what I like about this slide here is that it takes you through the steps. Okay. So let's go look at the points. Right now, this is the decimal too. E is at 0, 1. D is at 0, -4. F is at -3, -3. So what does the first step say to do? Subtract what? Subtract the center from each of the points. So let's start off with like E prime. What is the x of point E? 0. And if I subtract the center of dilation, and somebody had mentioned how they happen to be negative both coordinates, what happens when you subtract the negative? You actually end up adding, yeah. So +5, and then the y is 1, that also happens to be +5. So E prime is going to be at 5, 6 right now, after this step. Not at the end, just after this step. Let's change the color. And now let's do F prime. F starts off at -3, -3. So if -3 is the x, then we're going to add 5, just like we did over there. And -3 happens to be the y, you add 5 also. So F prime is at 2, 2. For now. For now. For right now. And then the last one, tell me if you can see it purple. What, D? We need to do D. So D prime starts off at 0, but then +5. Starts off at -4, but then +5. So after this step, we're at 5, 1. Not done yet, but that's where we are after the first step. What does the second step say to do? I apply the dilation rule, sure. So what is our dilation rule? It's whatever the scale factor tells us. What do we got to do with that 1.5? Not divide. Multiply. Yeah, dilations occur through multiplication. So now we're back to E prime. So that will be 5 times 1.5, comma 6 times 1.5. I just multiply both of them by 1.5. So here we had 5 and a 6. Let's multiply both by 1.5. Oh, here comes mental math. 7.5. If somebody has a calculator, double check for me. But I think that's 7.5, and this should be 9. 7.5 comma 9. I think I'm right. Okay, f prime would be then 2 times 1.5, comma 2 times 1.5. So f prime is 3, comma 3. You double check it for me, Luna? 5 times 1.5 should be 7.5. And then I know 2 times 1.5 is 3. I want to know. Any question that's all I got here so far? Finally, purple. D. 5 times 1.5, comma 1 times 1.5, and that's gonna give me 7.5, comma 1.5. But I'm still not done, because now what do we have to do at the end? Go back to that center of dilation, but instead of subtracting it, now we're gonna add it. What happens when you add a negative? Yeah, subtract. So E prime, now this is the final step. E prime is going to end up being at 7.5 minus 5 and 9 minus 5. It just happens to be that for the center of dilation, both coordinates happen to be the same, so we're doing the same thing each time. But like if this would have been a -3 instead of, if the y would have been a -3 instead of a -5, here we'd be adding 3. Up at the top we would have subtracted 3. X's go with X's, Y's go with Y's. Jaden, can you take the hood off, please? 7.5 minus 5 is 2.5. 9 minus 5 is 4. So 2.5 and 4. I don't know, I guess maybe green. Let's use green to plot this. So E is going to end up at 2.5, 4, 2.5. Now, before I even graph anything, was this an enlargement or a reduction? Enlargement, yeah, the scale factor is greater than 1. So I should be getting a bigger triangle than I started with. Let's do it with the F's. F prime. F, we left, the last time we saw F, it was at 3, 3. So now it's going to be at 3 minus 5 and 3 minus 5. So that gives me -2 and -2. Which is down here. So this is F prime. Up here was E prime. I know it's a little hard to see the green. And finally the purple. D prime is at 7.5 minus 5, 1.5 minus 5. So D prime ends up at 2.5, -3.5. 2.5 -3, so somewhere around here. The reason why it seems off center is because the reason why it looks like it also slid. Can we agree that the green triangle is bigger than the black one? Yeah, it's 1.5 times bigger. Okay, but the reason why it also looks like it slid is because we moved the center of dilation. Question? No. And I'm gonna leave this here. If this comes back up to review, fine. But I'm any other dilations today, I'm just gonna do around the origin. And then once we run out, I was gonna go back to rotations today, but since we're not taking the quiz tomorrow, we'll have plenty of opportunities for rotations tomorrow. It's pretty neat. Here, you can take, I'll give you one today, Miss Lamb, so you can look at it. I kind of like this.
Is this when you're getting the computers tomorrow? Is it tomorrow?
No, that's Monday. This one I'm gonna actually
This is tomorrow.
Yeah, I'm gonna give them a
Okay.
paper copy of this, and then I'm gonna put that on the board and have everything on there.
Okay, I'll get it.
Okay, this one we'll skip because it's different center of dilation. Okay, here we can do this one. Let's see who remembers from yesterday.
Can I have this copy? Do you have an extra?
Yeah.
Okay.
Find the center of dilation for the given figures and determine the scale factor. Who remembers how I told them we can find the
draw a line?
Well, you're using your hands, but Jamal, oh no, Josh and Jamal are saying it. Oh, you guys, because you're covering your mouth, and I can't tell who's the one talking.
You draw a line.
From where?
Pre-image to
The top,
intersection.
what he said, high five. Thank you.
Connect each point on the image with its pre-image. Now this is actually a pretty bad example because here we don't even know which one's which.
You don't tell me?
It doesn't know. I don't see prime notation. No. No, you can't be sure. There's no way to be sure. This could have been a reduction. It could have been a dilation. I guess we really don't know. But I don't see a line tool up here. So I'm gonna have to draw this freehand. So yeah. So let's see if I can do this. I connect one of the A's with the other A's, and I keep on going. I connect one of the B's with the other B, and I keep on going. I connect the C with a C, and I keep on. So this, it looks like it's a little off, but I also don't have a line tool. Oh, maybe I do. Okay, I can use that. I can use that.
No. They're not.
Line. Perfect. You gotta love technology, huh? So this still looks a little bit off, but it's just because I think it's just because the actual graph is a little blurry. Maybe I might have been off just a little bit, but it looks like this is gonna be the center. That looks like it's 3, -2. It looks like it's 3, -2. Okay. Now we don't know if this was an enlargement or if it was a reduction, but this is not the best one because I have to show you distance formula to do this. I'm not sure if I should. Let's forget about this one for now, because in order, if I would have had horizontal lines with vertical lines, it's easier because you can just count. But here everything's diagonal. I need distance formula. I haven't shown you distance formula yet. I don't want to confuse you yet. So, do we at least know how to find the center of dilation? And that was it for that. Good. So now let's go to this little supplemental unplanned lesson, which the good news is might be a review for you. I'm hoping. Well, I know that if you've taken Algebra 1 already, as your credit history stated, you should have heard of at least some of these.
Slope, yeah, should have slope.
Yes, the first one is the one I would assume you've definitely heard of. It also that might not necessarily be a good thing. I mean, you might like it, but you've heard of it. So here's what I want to point out to you. And I'll try to make this quick so we can finish it today so that tomorrow we can just do the review lesson, the activity. But watch. If I were to get any 2 points, and put 2 points on a plane, there are 3 measurements that we can take with regards to those 2 points. And they all measure something different. I would assume you could guess from looking at the slide that those measurements are slope, distance, and midpoint. But I want you to be able to compare and contrast. So the ones that are mistaken the most are these 2. Slope and distance. People confuse those the most. Midpoint, you might argue, is the easiest. It's also kind of off to itself. But the first 2 are somewhat mistaken. Let's actually start off. The first slide is slope, but let's actually start off talking about distance. What does distance sound like? How far away? Yeah, length. So, yes, one obvious measurement I can take with these 2 points that I draw if I wanted to, or I can measure them. And if I put them on graph paper, even if I don't have like a ruler, but I put them on a coordinate grid, there's a formula I can use to measure how far away the points are from each other. Now, slope incorporates distance, but it's not distance. Slope is the steepness and the direction of a line. In algebra, you might have heard the phrase rate of change. Because in slope, what we do is, yeah, we incorporate distance, but we incorporate horizontal and vertical distance. So I'm not necessarily worried about how far these points are from each other in a straight line, but how far they are horizontally and how far they are vertically. Slope is a ratio. Who knows what ratio stands for? What's a ratio in one word? You can tell me in one word. Is your name Ryan too? I have 2 Ryans in here. Ryans. Ryan and Ryan. A ratio is a fraction. So when you think of slope, think of fraction. What helps you remember fraction? I know you've heard that, right? Slope is rise over run. What's that over in rise over run? What's the over part stand for? The fraction. Yes, fraction. A ratio is a fraction. Now, what are you dividing? What's this? What the heck? Look, I've heard of rise over run, but I've never heard of that before. In math, a lot we use Greek symbols, letters from the Greek alphabet. So I know it looks like a triangle, but in the Greek alphabet, that's referred to as delta. You've heard of like Delta Airlines, which is stationed here in Atlanta. You look at their logo. Yeah, triangles are prominently featured in their logo. Yeah. Sure, very good. Yeah, fraternities and sororities. They use the Greek alphabet. Sure. Delta, pi. Look, pi is a math word. Sigma is a math word that we use a lot. Alpha, beta. When you learn trigonometry, theta, when you get into trigonometry. In statistics, mu is also used a lot. So you see Greek letters. So this is the Greek letter that stands for delta. In math, delta means change. If I go to the store and something costs $7.58 and I pay with a 10, and I want to know what's my change, what operation is the cash register doing? Very good, subtracting. If when Ryan got here as a freshman, he weighed 202 pounds, but he wants to beef up for the O-line, and he wants to get up to 320 by the time he's a senior, and I want to know how much his weight changed subtract. Which that gives us, guys, we're about to make connections and then you're going to have your aha moment. This horizontal distance, that's delta x. This vertical distance, that's delta y, also known as the rise and the run. Once you divide those, the way that, how many points are we using to find slope? How many points did I draw on the board? Two. So if you get those 2 points, this is going to be available online too. By this afternoon, I wasn't planning on it. I was kind of do this in last minute. This is available under today's. I put it under today's lesson. And here you go. Here's slope formula. When I give you a reference sheet for Tuesday, I'm going to include this on there.
Doesn't the 2 go first?
Very good question. I hear that a lot. Doesn't the 2, every single time I've seen this, it's y2 minus y1. Well, Stefan, if I were to put 2 points on a plane, can you tell me which one comes first?
Yeah.
I can't.
Huh?
It's just a way of writing it. If let's say that, if I want, if I choose to call this point 1, then that would make this x1 and y1. If I choose to call this point 2, then that would make this x sub 2 and y sub 2. But regardless of which one I put in first, the slope between those 2 points is still going to be the same. Now, what I will tell you, Jaden, as well as Stefan, okay, what hopefully you can gather from this is it doesn't matter which y you put first. It doesn't really matter. If this y here was a 5 and this one up here was a 7, you can either put 5 minus 7 or you can put 7 minus 5. That doesn't matter. As long as on the bottom, whatever y you put first, you have to put that x first also. If right now when you're here, my head is blown, I just don't get it, I'm so confused. Okay, then go back and use y2 minus y1. I'm just trying to prove a point that doesn't make a difference. But that is the way that I learned it. I had Algebra 1 last year. My teacher taught it to me that way. And fine, do it that way. Same thing. The reason I do it this way is because when they don't give you a graph, when you're not looking at a picture, and they just actually list the points for you, I believe that we have trained ourselves to read from left to right. So when you look at 2 points, my eyes are more comfortable looking at left first and then the next one. Left first and then the next one, as opposed to going to the right and then coming back left. But it doesn't matter. Is that your thinking face? You still seem kind of...
No, I'm...
Okay, all right. Okay. You get it? Okay. So, the last thing about slope is that when you perform slope formula, we can categorize slopes. There's 4 different types of slopes, and that depends on the sign. I set up here that slope is the steepness and direction of a line. What does that word steepness sound like?
The hill goes.
Okay, sounds like a hill. Some might call it an incline.
Something like
Ever been on a treadmill before?
Oh, yeah.
Yeah. Obviously, one of the settings is speed, but what's the other one? The incline. Sure. And what happens when you start hitting that?
it goes up.
Well, I always love when they say that, like, because to me that starts flying off the ground. No, it doesn't go up. The entire treadmill does not begin to levitate. But what happens? It gets more inclined. It gets steeper. It gets steeper. So when you use slope formula, the bigger the number that you get, the steeper the line is going to look. But slope is also going to give you a direction. It's going to tell you what direction it's going to go. And that's determined by the sign. So here, positive slopes. All positive slopes go in this direction. But so that we're not trying to do hand signals like earlier and we can use words, let's try to use our words to describe to me, what direction do you see the red line going?
Up and down.
Very good. Up and to the right or
Down
and to the left. Good. Can I write that in? Positive slopes go up, right, or down and left. Up, right, down, left. Once you use slope formula, if you get a negative, all negative slopes travel in this direction. Let's use our words. Oh, Harley, very nice, good. Up and to the left and down and to the right. And then we have kind of our special cases, which these they do involve math, but as much as math is involved, it's memorization. Zero slopes and undefined. It says like you kind of have to memorize these. What do you think? What do you think a zero slope would travel? Use your words. Horizontal would work, sure. If we want to use directional words, I would say left, right. There is no vertical movement. There is no rise, only a run. That leads me to my next thing. Like I think, especially I can tell Luna, I'm training her to write things that I say and not that she sees. That I can see her getting better at that. So I would advise all of you. How would a zero slope look like up here in slope formula? If there is all run and no rise, what do you think I would see and where would I see it? It's definitely going to involve a zero, that's obvious, but where is that zero going to be?
Why?
No rise, it's all run and no rise. Yeah, there would be a zero on top. After you subtract. After you subtract, if you have a zero on the top, that's going to be a zero slope. And you need to memorize this because if you're not looking at it, if you're looking at a picture and Jamal looks at this and goes, oh, hey, it's horizontal, sweet, that has a zero slope. But what if I can't look at it? You gotta subtract first. When the subtraction is done, if you have a zero in the numerator, and then where do you think an undefined slope is gonna go? Vertical, all rise, no run. In slope formula, what do you think if I can't look at a graph of it on slope formula, what do you think would happen? Where would the zero be after you subtract?
Zero will be on the y side.
On the bottom. Yeah, down here in the denominator you would end up with zero. So for a zero slope, zero on top, undefined, zero on the bottom. So I got my 10-minute warning on my watch, so let's just move on then to distance. Let's say I did want to figure out just how far those 2 points were from each other directly. Here's distance formula. Still 2 points, but now there's 5 steps. The first one is substitution. You would plug in the x's where they go in the y's, but then the first thing we're going to do is subtract. Subtract the x with the x, the y with the y. Stefan, unlike slope, even if you mess up the order here, it doesn't matter. Because the only thing, when you subtract, the only thing that could happen if you get the order wrong is you might get a negative when you should get a positive or vice versa. But once the second step comes along, what happens when you square a number? What do you always get? You always get a positive. You always get a positive.
Wait.
A number to the second power is always going to be positive. Like question mark, why? Because what's a positive times a positive?
Positive.
But what's a negative times a negative? Any number times itself is positive. Any real number times itself is positive. Okay? Then you would add, and finally at the end you would square root. I can maybe get to an example of that before we go. Midpoint also requires, if you don't write this all down, it'll be online by this afternoon. Midpoint also requires 2 points. This is considered probably to be the easiest because all you're doing is taking the average. You're adding the x's and dividing by 2, and then adding the y's and dividing by 2. And that will give you, now midpoint, all that tells you is, where's the point in the middle? Let's make more connections. What can you also call that? What does a midpoint do to a line segment? Let's use a word that we learned. What does a midpoint do to a line segment? Close.
Oh, Jamal, you're trying. Use your words.
Josh said good. I heard Josh say something. He said intersect, but there's a better word than that. Bisect. Good. Bisect. Was that you, right? Okay, let's do a couple quick examples before we go. Let's first do distance. I cannot see these points, but I have 2 points here located at these coordinates. And I want to see how far they are from each other. The first thing I want to do is substitute. But remember, with distance, I guess we could say with all of them, it's x's with x's and y's with y's. So what are my 2 x's here? 5 and -3. I'll show you a hint. Whichever one you decide to be second step, and if you want to think of the first one as S and the second one as R, that's fine. I like to go from left to right. So I'm going to consider the S's to be the second one. When you plug them into the formula for distance, change the sign. Not for midpoint, but for distance. So I'm going to see for the X is 5, not -3, but +3. I'm going to see 1. I leave the first one the same. Instead of -3, I'm going to see +3. You can just write the plus there. I just kind of circled them to show people why. We have until 16?
16.
Okay, good, sorry. I just want to do one example of distance and one of midpoint. I'm not going to worry too much about slope, but I just wanted to throw that in there just to give you a review. But I care more about those 2 hints. Okay, so now let's just do order of operations. PEMDAS. What did I tell you is going to come first? Okay, it is parentheses, and it's supposed to be subtraction, but because of the change of signs, it happens to be that in both parentheses we are doing addition. 5 plus 3 is 8. 1 plus 3 is 4. What comes next? Okay. Exponent. And even if I would have had a negative, this is super important. Super important. Because even if you screw up, you can correct the mistake here. Okay. Just know that when you do a square, you have to get a positive. So like, let's say you messed up with a sign up here, and maybe you got like a -4 instead of a +4. As long as on the next line you get a +16. Correct, that's what I'm saying. Like, but let's say maybe up here he put them in the wrong order, and instead of getting a positive, he got a -4. You know, just make sure that he doesn't get -16. Okay, then we add again. And the last thing that we're supposed to do is square root. We are going to have to simplify radicals at some point this year, but we'll worry about that later. So the thing is, when you put this into a calculator, you get a decimal. So for right now, if that were to happen to you, you're allowed to round. Hold on, I can still finish. Let's compare and contrast. After I plugged in these points, what's the first operation I did? It happened to be add because of the signs here, but in reality, what's the first step? I subtracted. This is the first thing I did was subtracted. Eventually I added at the end, but I subtracted, right? With midpoint, let's now do midpoint, which is much more quick. Let's find between these 2 points what would be the point in the middle. Still x with x, still y with y, but what we're gonna do is add them. When you add, you don't change any signs. So if I add a -14, that 14 stays negative. The 12 stays negative also. And then divide by 2 always. Just get this written down. You'll see the assignment on this already tonight, so you can start practicing it. But on Monday, we'll be able to work on this in class too. And the stuff on this will be due on Tuesday. You have an extra day. Tomorrow, we'll go back to reviewing transformations. Any questions for me? You can sign out.